Welcome to the OpenUSD Insiders live stream series. We're going to be covering route planning with NVIDIA cuOpt, part of Robotics Office Hours, which you'll recognize some very friendly faces here with us and some new faces. Today, we're going to try to make this a hands-on session, which is why we're starting a few minutes late. We're trying to figure out how to connect one of our additional computers here so we can go live and show you some examples. Hopefully, we'll get that working before the end of the live stream. Otherwise, we got a backup plan to go through the documentation. But we have a lot planned for today. We're gonna show hopefully how to build waypoint networks, call the cuOpt service, tell you more about what cuOpt is, visualize optimization data and Isaac Sim. We'll go over what Isaac Sim is if you're not familiar with Isaac Sim. Then we'll run into an intra-warehouse transport demo to show how robots are planning and adapting routes in real time. Absolutely. Leverage a live chat. Tell us where you're watching from. If you're working at a company or project that touches on anything we're talking about, absolutely feel free to share that in the chat. We'll take your questions and comments along the way. Don't be shy. We're going to be stopping at different points to do that. And we will cover any news, any general news topics at the end of live stream. So if you want to find out what's coming up with GTC and some other sessions and blogs that we released, I'll cover that stuff at the end so we can jump into the media topic just to get things going. So here we go. Let's us talk about the guest first of all. Next to me, Asari, so nice to see you.
Yes, hi everyone. Thank you all for joining. I have been on some of our previous live streams and office hours. Maybe you've seen me. I work on the tech marketing engineering team for robotics. So I get to work with all of our cool robotics platforms and share it with everyone.
So
Excited to hear about cuOpt from everyone on the team today and have a great office hours.
It's going to be a lot of fun. And we have another guest here. Burchin, how are you doing?
Doing well, thank you. Yes, I'm Burchin Boskaya. I'm a senior developer relations manager working at NVIDIA. I'm the person trying to bridge the gap between our cuOpt development and product teams and the developer community out there. So I help people on board with cuOpt.
Amazing. Well, you're going to be very much in demand for this hour. And veteran live stream co-host, we have Ashley. Hey, Ash.
Hey, I am Ashley. I have been on a few live streams, but never the Robotics Office Hours. So very excited about that. I'm lead tech marketing engineer for Omniverse. So I help the developer community get started with Omniverse SDKs and libraries, get you introduced to all of our great learning paths and community stuff on Discord and forums. So very much involved with all of you and excited to learn more about cuOpt myself.
Amazing. By the way, I just came back from New York City where we had our first Omniverse meetup, and several of them said that they've learned so much from your live stream. So that they love the Learn With Me series. So we'll, I told them we're working on getting something with that format back in the future because it's so great.
Yes, for sure.
Okay, we're also joined by another first-time presenter. Ashika, thank you so much for joining us today. Tell everybody about what your role is.
Thank you. I'm Ishika Roy. I work on the cuOpt stack. And recently, I've been also working on the Isaac Sim and cuOpt integration. So I'm really excited to be talking about it today in this office hours.
I'm very excited too. So we have another guest here. She's working on a setup. I'm going to ask her right now. Hey, Edith, do you want to say hi really quick, or do you want to keep working on your setup? Okay, she will still say hi. Let me bring up Edith. Use our special button here. There she is. Edith, thank you so much for joining. I know you're working in the background trying to get the second computer set up, but while we do these intros, why don't you tell everybody a little about yourself and what you hope to cover today?
Yeah, of course. Hi, everyone. My name is Edith Lontop. I am a robotics technical marketing engineer, and I will be covering a live demo of cuOpt. So very excited to get to show you guys that in the future, but working in the background. So we'll let everybody kind of speak, and then we'll get to my topic towards the end.
Awesome. So great to have you here. And I think Edith I'll be a regular on these live streams. So we're really excited about that too. All right, Edith, I'm going to let you continue working in the background. I'll bring you back up in a bit. All right. So I think it makes sense. We talked in our warm up, we talked a little bit about doing a high level overview of some of the main terms we're going to go over today in tech. And I think it probably makes sense to start with Isaac Sim. For those who have not worked with Isaac Sim, you're going to love what it does. And we're just ecstatic by the adoption rate of Isaac Sim and Isaac Lab. We've seen just a massive explosion, I think, in developers that are using it, and for good reason. So I'll let Asari kind of go into what Isaac Sim is and what type of developers would really want to use it.
Yes. So Isaac Sim is our simulation platform. It's built on top of Omniverse. And when you think of simulation platform, there are a couple of key features that you want and that Isaac Sim provides. So one of them is photorealism. That means that any object that you bring into Isaac Sim or any of the, because this is the Robotics Office Hours, whenever you import a robot into Isaac Sim, everything looks very realistic. So anything rendered from the simulation kind of looks like it could have been captured in the real world. Now, the reason that this is an important feature is that whenever we train robot models or visual models, if we train them on data collected in simulation and then deploy it in the real world, if simulation and real world did not look the same, then a lot of these deployments would fail just because they've not been trained on data that looks real. So again, key feature of Isaac Sim is the photorealism, the fact that you can get very realistic looking colors and textures and lighting. And you can create all of those simulations to match the real world scenario. That's why this is very important for robot training. Second thing is that it's very physically accurate, which means that all of these physical interactions that happen between objects in the real world can be mimicked or simulated very closely in Isaac Sim. So just some examples are whenever you have to grasp an object, whenever a robot is picking something up, let's say, then there are certain forces at play here, right? Like the robot hand cannot go through the object, for example. It needs to have an awareness of the collision spheres and how it can actually grasp. So this is one example of how you need to accurately mimic the physics. Another more basic example would be, let's say we have a robot somewhere in the environment, in the simulated environment. We don't want it just like levitating as if there's zero gravity. So gravity is another real physics property that has to be imitated in simulation. So these were just some examples, but a lot of these realistic physical qualities that you want in the simulation, Isaac Sim provides those as well. And to do this, it can use a couple of different physics engines. One of the most common ones that you may have already heard of, it's called PhysX, like the letter X. And then we are working towards building in more options for physics engines in the background as well. And the latest release for Isaac Sim, it was a few weeks ago, and it was called Isaac Sim 5.1. So with this release, we have a whole bunch of getting started tutorials and more advanced tutorial as well. And mainly to be able to create very realistic simulated environments, such that whenever you train and test and collect data in these environments, you can deploy it into a very realistic scenario in the real world as well. So a couple of places where you would use Isaac Sim, and maybe a lot of you on the office hours already do this. One is data collection. So creating a simulated environment and then also mimicking sensors, realistic sensors in this environment. So things like a LiDAR or a camera or a depth camera as well. All of these can be imitated in Isaac Sim, and then data that is captured through these sensors can be used for training real robots. So data collection becomes one important use case. Another use case is if you have a trained model and you want to see how it would perform, but you don't actually want to deploy it on a physical robot. Because with a physical robot, there's always a risk of failure. There's a risk of damage, right? And it could be quite expensive. So you want to do all of that on a simulated robot instead. So that's another good use case, just testing a lot of models and AI policies that you may be training, test it in simulation. And then when you're reasonably sure it's performing well there, then you can deploy it in the real world. And then there's a higher chance of success in that case. So yeah, these are some of the main ways people and developers, we all use Isaac Sim. And on the Discord, I'm sure we've been having a lot of discussion about how people are using it for different use cases across different domains. Today, we're going to be learning about a very interesting use case. It's called the cuOpt framework. And cuOpt is about route optimization in simulation, how you can do this. So we have Burchin here who's going to explain a few key properties and give us an introduction as to what cuOpt is. I'm excited to learn too. And from there, we're going to see some examples of using cuOpt.
Amazing, amazing. And for those who are just diving into Isaac Sim now, I see some new users chatting in the chat, which I see other users helping each other too in the chat, which is great. There's a couple of great places you can go to find out more. Obviously, the Isaac Sim documentation page. We have official support forums where our developers help. And then we have other developers in the community that help each other on our Discord server. So three great places to go. Burchin, let's dive right into it and talk about what is cuOpt and what do people need to learn to get into it.
Sure. Yeah. Thanks, Edmar. Would you mind sharing my screen?
Here you go.
Here we are. Yeah. Thanks everyone for joining. So yes, I'm Burchin Boskaya, Senior Developer Relations Manager for cuOpt. So what is cuOpt? cuOpt is NVIDIA's decision optimization library, an open source library that solves complex optimization problems which arise in many different contexts and verticals, right? Like the ones that you see in the screen. So in a variety of domains: supply chain optimization, last mile delivery, scheduling, portfolio optimization. And specifically today, we're going to be looking at its integration with IsaacSim and also solving routing optimization problems, which is one of the key strengths of cuOpt optimization library. So we've been developing this for the past 3-4 years. It's actually won a lot of world records and awards and whatnot in the meantime, from the VRP side of things, like routing optimization. And it's not just about routing optimization. It can also solve other types of problems that are represented as linear programming optimization models or mixed integer programming optimization models. So it's actually more than just routing optimization, right? So it's open source. We have recently open sourced it back in May. It's production ready, so you can take it, build it, customize it, and deploy it in your workflows. You can integrate it with various other tools that are out there in the optimization world, different platforms, model building tools like Ample, CVXPy, GAMS, and Jump, and others. So cuOpt does all of that essentially by running intelligent search algorithms on the GPU, like highly parallelized, using GPU cores when solving these problems, in a high speed and scalable way. So it builds these solutions from scratch by looking at multiple alternatives simultaneously, searching the space for trillions of solutions, depending on the size of the problem. And it does it very fast on the GPU. I mean, that's the whole idea, right? So that also enables like decision makers and analysts to make like a lot of real-time decisions if needed because of the speed that it brings. We have recently released version 2510 cuOpt, and again, this is open source and GPU accelerated library that comes in 3 flavors, if you will. I mean, 3 different types of solvers. So the one that we're going to be looking at today is the VRP solver. It's a heuristic solver that runs on GPU, highly parallelized, very fast. But like I said, we also have linear programming solvers on GPU, like the PDLP and barrier solvers, if you are familiar with this domain, and dual simplex solver. We also have something called MIP heuristics, primal heuristics for the mixed integer programming type of problems, and which are a lot more complicated problems. And like I said, we open source this, in order to energize the community and, have broad adoption, broad traction with these solvers, so we can help developers and decision makers, accelerate and speed up their workflows as best as possible. Yeah, how is cuOpt available? So if you wanted to use this today, how can you be using this, right? So it's open source, obviously. So you can go to our repo, get the source code. If you want, you can build it from source. But we also offer many other things to help you facilitate, ease of adoption, ease of use. For instance, we have packages built for pip and conda, so you can pip install, conda install cuOpt. We have instructions on that repo page that you see on the screen here, NVIDIA cuOpt repo on GitHub. We built containers which are available on NGC, NVIDIA's platform for accessing a whole variety of containers and other resources, NGC, and also available on Docker Hub as a container. So yeah, I mean, and then these are also built nightly. So I mean, because it's open source library, cuOpt, we continuously push new developments and feature enhancements, PRs and whatnot. So we provide nightly container builds for developers out there who are always looking for the latest and greatest. And so cuOpt also comes with these API options, right? So C API for LP and MIP solvers, Python API for those 2 solvers plus the VRP solver, which is what typically routing folks use in addition to the container access. We obviously offer the container access and then the HTTP with the RESTful requests over the server, client-server kind of structure. Those integrations I mentioned before with Ample, GAMS, Julia, that are available for developers who are already building models, routing models, or other models on some of these platforms. And we have more to coming up with Pyomo and SciPy. If you want to try it out, we have several ways of trying this out. So we have some example notebooks that you can run on Google Colab. And the links for these are also available on our website, the repo site. We have also something else called NVIDIA Brev platform that offers what we call a launchable, where you'd be able to launch one or more of the notebooks that we have prepared for your evaluation or testing. So these are available, again, through the repo. We have lots of information, lots of links and resources there. The container itself is a microservice that pretty much works in harmony with the rest of NVIDIA software stack, other microservices. So similar concept, it's a microservice. You can deploy it in production. It's optimized for latency, and in the case of cuOpt solver, it's optimized for the particular hardware infrastructure that you have, like H100, A100, and whatnot, industry standard APIs. So yeah, these are all available to developers today. And cuOpt is also part of what we call NVIDIA AI Enterprise. So if you are looking into deploying cuOpt in production as part of your enterprise solution stack, solution offerings, you can do that through either the container approach or other stack other API options that we provide. And NVIDIA AI Enterprise means we also offer production level support when you deploy cuOpt in production. And last but not least, if you wanted to get started with cuOpt, so we actually, for the VRP solver, we have a nice environment, nice platform and sandbox for you to give it a try. We call it the NVIDIA API catalog. It's build.nvidia.com. If you just go there, search for cuOpt, you're gonna see the cuOpt API example, be able to load your problem, the VRP problem, and send a request, and it will give you a solution. But this is generally for evaluation and learning purposes, right? So it's not meant for production purposes. If you want to obviously go for production level deployment, then you would want to sort of get either the container or other packages installed and then deploy them on your own infrastructure or on the CSP, cloud service provider. Like I said before, it's also available on Google Colab and NVIDIA Brev Launchable for LP and MIP solvers. And obviously, it's available on GitHub. And we have a separate examples repo called cuOpt examples GitHub repo that has a lot of notebooks available. So yes, and full-scale documentation describing all API options, function calls, everything. So yeah, it's available for all of you to give it a try, and I can answer any questions if you have afterwards. But this is cuOpt, and it nicely integrates with a lot of workflows, like the one we're going to be describing today with Isaac Sim. So I'm gonna stop here and pass it on to
Amazing. Well, I have a question right away.
Sure.
This presentation is full of really great information. Is it possible we can make this deck available to viewers? Not this second, but maybe later today. We can clean it up a little bit if anything's not public, but it sounds like everything is public.
Yeah, we can make it available.
Okay, that'd be great. All right, so anyone who's watching, what we're going to do, we'll add the easy way to add the deck is to put it on Discord. So if you go to our Discord server, I'll post a link in a minute. I'll create a thread for this live stream, and we'll put the deck there so you can follow up afterwards. And we do have a couple of great questions. I think that one of my colleagues here has starred. So let's take these really quick while we're on the topic. I see this is coming in from Mark over on YouTube. So thanks for watching, Mark. Mark is asking, are the cuOpt servers working on DGX Spark GB10 CUDA 13 right now?
Yes, absolutely. Yeah, I mean, we just started distributing that, right? DGX Spark is getting very popular lately, and yeah, I myself tested it many occasions myself on my own DGX Spark, and it does work.
That is awesome. Okay, and then we have a great question also coming in from YouTube, asking if we have an example of running cuOpt with Robot and Isaac Sim.
That's coming up next. Yeah.
Okay, here we go. So that's a great. I did not ask that question. That came in from a viewer. I wasn't trying to cheat. Okay, so here we go.
Question because it was just exciting to say that that's what we're showing today.
Yes.
So.
Yeah, I'm glad that's on everybody's mind.
Okay, very cool. Well, this is fantastic. All right, so let's move along then. And I think Edith, you want to try?
Hello. Yes. Edmar, if you could share my screen.
Let me see. So right now, okay, I'm not seeing your screen yet. Oh yeah, am I seeing it? Let me see. Because right now I have the one screen for you, which is the webcam. Are you sharing another screen in StreamYard that you see on the bottom?
One second.
I see the video we have queued up, which I think we talked about a little earlier, but okay, we're gonna let Edith continue to. Oh wait, hold on a second. Let me see. Do I see something popping in? Not yet. Okay, keep working on that. You'll know when it's sharing, when it shows up at the bottom. I think you'll be able to see it,
Okay.
and then I'll be able to see it also. Well, we try to get that figured out. That's what we're trying to work. The issue is that she's working from a different type of workstation with Linux, and we're trying to get StreamYard to recognize the screen for sharing. So that's what's happening in the background. But while we try to figure that out, Edith, the other thing we could do is one of the other people on the stream could maybe share the documentation, and we could potentially go through that first, or if Ishika, you want to go over some of your material, and you also have this video down below that we have queued.
Yeah, we can definitely share and go through the documentation, at least so everyone has that available to them when they want to get up and running. And then Edith, if the demo is working by that point, then you can share that as well. So I can share my screen so that, because I have it up.
And then just bringing that up real quick, just to confirm. Does cuOpt work on the Thor? I believe yes. Is that right?
That's for Burchin, I guess.
Mm-hmm.
On what? I'm sorry, I missed it.
Sure.
On the Jetson Thor, the edge device.
We haven't tested it on edge devices, cuOpt. Short answer. But we're looking at
as CUDA, maybe as long as the CUDA dependencies are met.
Yeah.
It probably should work, but yeah, we haven't tested.
Yeah, correct.
Okay, fantastic. All right, so thank you for that great comment. Ashley, I see your screen. So, okay, now we can look at the documentation page. I think let us know in the chat if the font is a little too small and we can make it bigger, but I think it's okay.
There you go, made it bigger.
All right.
You don't even have to tell me. I also cannot see. So, all right, this is something I definitely wanted to share regardless of the live demo or not, because it is a great piece of documentation to help you get up and running for the latest of Isaac Sim 5.1. It's a pretty quick tutorial. The document says only 15-20 minutes, so pretty straightforward. And all the resources that you need to get up. It has like your prerequisites. It has the examples. I've not run this myself, so I'm not familiar with actually how it works. Ishika, I know that this was something that you co-collaborated on authoring. Is this something you can speak to a little bit on the importance of like this example running in Isaac Sim?
Yeah, so these are like really basic examples and tutorials just to get you started. So these are very small scale examples to get the user familiarized with how Isaac Sim and the cuOpt integration work. So the first couple of examples, the first example is just how to create a graph network, which is basically when you're routing your robots through intra-factory, how would you start off with generating the routes and establishing all the infrastructure first. So that's the very first example. Then the second and third example, which is the cost matrix and waypoint graph, help you go through how you generate and initialize these graphs in a format that cuOpt can understand and ingest. And the last example, which is the intra-warehouse transport demo, is what brings it all together in a factory digital twin to show you an end-to-end pipeline of how cuOpt routing would look like, and the capabilities that it has in rerouting within seconds to create new routes so that there are no delays in the factory. And these are very small scale, as I said. These need to be scaled up for real world examples, which I'm going to be probably talking about in a couple of minutes.
Yeah, and the great thing about this documentation as well is it goes over the different extensions that help enable this workflow. So it gives a breakdown to why these what these extensions do, to wrap around the cuOpt service and the utilities for generating that scene data. And then it also goes through all of the different examples so that you know what you're to expect when you're actually running it. And it gives you a step-by-step on actually how to do it. So there's that first one, that create network one. It walks you through it. And this is what Edith was hoping to show in her live demo as well. The simple cost matrix one, what you can expect and how to get it set up. It even goes over the different setup, the section for the problem setup for your fleet size, vehicle capacity, number of locations, and solver time limit to give you a more detailed explanation. Goes through all of the open source code and then into the next few examples as well. So it is a really great piece of a tutorial. If you're interested in integrating cuOpt into your Isaac Sim, I recommend getting this started, and it's actually not too hard to do. Edith was able to get up and running in just a couple of days.
Yeah, I just want to chime in that these are pretty detailed. Like we've made sure that we have all the visual representations as well of what the user should be seeing and expecting. So hopefully it's easy to implement and get started with.
Amazing.
Yes,
and let us know in the chat. We're seeing some good questions and comments here. But I think the documentation, at least from what I'm looking at, looks very good. And Pratham here agrees. So we've done a lot. I think the team has done a lot over the last few months, especially to really improve our documentation based on great feedback we're getting from the community. So it's a great example of that. And okay, I'm going to bring Edith back on. Let me see if we can. Hey, Edith.
Hello. Oh gosh. Okay.
Listen.
I really want to show everyone this demo here, so I'm gonna try one more time.
Okay.
And see if this is working on my end.
It wouldn't be a live demo if something didn't work, right?
Right. Okay.
Oh, hold on. I see something.
Can you see?
Yes. Hold on.
It's a little slow.
I have to remove this one. 1 second.
Yeah. So you should be able to see kind of
sorry.
my terminal and the documentation pulled up kind of side to side.
We do.
Awesome. Okay, perfect. Oh, this is great. Okay.
All right, so let me do this actually. I'm going to remove our webcams because I think it'll make it a little easier to see the screen for everybody. So
yes.
Let me try. I think it's this one. Does that help a little bit? Okay. So I think let us know in the chat if this looks okay, and you can kind of. Well, I think it looks good.
Okay.
Yeah.
Just let me know when.
Okay. You have full control now.
Perfect. Awesome. So yeah, thank you to the person that posted that question on Isaac Sim. A great segue into what we're going to be talking about today. So I am following this documentation straight off of our official Isaac Sim documentation that my fellow teammates just kind of walked you through. So let's actually dive in. So we have documentation on kind of like installing Isaac Sim and getting that working on your local workstation. I won't be going through that, but if you are interested in getting this running on your end, just make sure you kind of click on this installation tab and go through all these steps there. But for our purpose, for our use case, we're going to be diving deeper into this demo here. So I'll get Isaac Sim running on my end, and we're going to be going through one of this the first examples here, which is kind of getting just creating this network and kind of creating what are going to be nodes and connections here. So it's a little tiny to see, apologies for that, but on the screen here, I am going to go to Windows, Extensions, and then in these extensions, I'm going to look for cuOpt, and then kind of press this toggle. So I enable all of my visualizations, a couple of examples, and the interface in general. So once I've actually kind of turn those kind of extensions on, I can exit out of here, and then I'll notice that on the top left-hand corner, you see a cuOpt tab. So once you kind of see this cuOpt tab, that means kind of like you're ready to go and you're ready to kind of follow the kind of examples on the documentation here. So first things first is we're going to want to follow this first one, where we're going to be creating a network. So we have our new Isaac Sim session created here. I'm going to go into this cuOpt tab here, create network, and then I'll see this little window pop up where I can create a node. And then I'll see a node kind of just like pop up on my screen that I can move up, down, and kind of just really place anywhere I want. So let's say I want this kind of node here. I'm going to create another node here that pops up in the center, and I'll be creating an edge between these two nodes. So the way that I do that is I can either select kind of by clicking, I select both nodes and then create the edge between them. I can also create additional nodes here, just playing around with the GUI, zoom out with just kind of scrolling through my mouse here, and then just kind of if I do the kind of clicking and dragging here, it won't work really well. So what I do is just I click the node and then press down on Shift and then click on the new node that I want to create another edge with. So kind of here, just we can work on creating multiple nodes and really expanding this network to something that can be a lot more complex. So you have the liberty, obviously, to create as many nodes and as many edges for your particular use case. And yeah, we can have multiple just kind of joining here, multiple use cases, and then just kind of having this go here as well. So that this kind of just allows you to play around with our Isaac Sim UI and play around with just kind of learning how to create a network. So hopefully this gives you kind of just the intuition on kind of how it appears on this side. So kind of moving along, let's look into kind of the next example that we have on the demo here, which is creating a cost matrix. So I'll create a new Isaac Sim session with Control N. I'm not going to save this for the time being. So I'm going to go back to my cuOpt tab that I have here at the top and then click on Simple Cost Matrix. And so here, something really important, there are kind of two different ways to, in this case, you can either connect to a cuOpt managed service or a cuOpt microservice. So if you are looking into doing this cuOpt managed service, and we have documentation for kind of creating your own API key for this, where you can just get more information on just like the model itself and just the architecture in general. Or you can also do this as a microservice, meaning that if you want to run this locally with your own kind of, we have steps at the very top. I'll just kind of preface this here with a cuOpt server, and this cuOpt server will kind of give you all of the instructions and the links that I pointed to, either the actual model card or the kind of like microservice. I could just open that up really quickly. And so you would want to go here, quick start. And so this is basically how you would do that installation in the back end, but just to save us some time, I already kind of did that. But all of the instructions are here and available for you to use. Just kind of wanted to highlight as to why, what these managed service and microservices kind of mean here in this use case. So for us, I'm actually going to be using this cuOpt managed service. Apologies for the lots of scrolling here, and I have my kind of credentials that I've have copied on the side here. So once you will get a API key from here if you want to do this by clicking this button. This is the one that I generated from my end. I just a random name. I'm just going to put cuOpt, and then the function ID will just be from kind of following the instructions that you'll get there. And then I want to make sure that the connection is working, and great. I see success cuOpt managed service is accessible. So step 1, I'm good to go for that. Those are kind of the instructions that you see in step 2 here. So kind of just cover through that. And then let's go ahead and kind of set up this problem. So you'll see a couple of values here: fleet size, vehicle capacity, number of locations. Let's dive deeper into. So the fleet size is basically the number of kind of like vehicles that you have in your scene. The vehicle capacity is the number of kind of stops that each vehicle will be planning on visiting, number of locations that have to be visited for these stops, and then the solver time limit, just to make sure that we get an optimized solution by a certain amount of time. So I'm going to set up this problem, and it kind of loads up a little zoomed in, but if I kind of move around here, I'll see the setup here, and then I'm going to go ahead and click solve. It's going to create, if you see, this kind of like intricate, oops. It's been able to kind of like solve this kind of like number determined by the number of fleets and that we have in this scene. So it's also able to return. I'm not sure if you guys can see very clearly here, but on the side we have the kind of the overall cost and then the actual routes. So kind of going from either like node 0 to 4, then 8, then back to 0. So this is kind of like a really optimal, just a very nice visual to kind of see. And then we also have the solution kind of popped up on the side here. Great. And then finally, let's kind of get into the Isaac Sim demo here. We also have a couple more waypoints. Just a quick check on time. Do you?
You can take all the time you want.
Okay.
You can go on for hours. This is amazing.
Awesome. Okay, just wanted to make sure. Cool. So let's move on to the simple waypoint graph here. So going to do the same thing, Control N. Not going to save the scene for the time being right now. I'm going to go back to this cuOpt window and load in the simple waypoint graph. So this might look it's going to take a little bit of time here to load. Let me try that one more time. cuOpt simple waypoint graph. New scene. Oh, for some reason it doesn't. Okay. I'm going to have to enter my credentials again.
You want me to take your screen off, or?
No.
Okay.
It's working. Yeah, sorry. Just so running this example with the simple waypoint graph. Again, want to make sure that I the same credentials that I kind of used for my earlier example. Just make sure I'm copying them here. So copy and paste, and then just gonna put a random just cuOpt name there. Test. Great. My the service is accessible, and so now we're going to actually click on this JSON graph here. So this might look a little bit familiar to the first example I went over, which kind of was just setting up a couple of nodes and a couple of edges inside of our Isaac Sim UI, but then here it's just a more kind of complex version. And so this is this kind of exists on a JSON file, but we also have a kind of USD file that kind of like exists along this. If you want to try that out, more than welcome to. But let's go ahead and kind of load some of our orders here. And so those are going to be denoted by these kind of green points that you see here in my UI. Hopefully I can make the screen a little bit bigger so you guys are able to see that. And then finally kind of go through loading these vehicles. So let me just talk about through what I did. So in this case, we have 7 loaded orders at nodes 12, 13, 22, 33, 32, 39, 45. And then we have 2 vehicles loaded at node 0, 0. So in this case, I'm going to press solve again. I'm going to let that run, and then I'll see the same output that I saw from my previous example. So vehicle 1 and vehicle 2 are denoted by the 2 separate colors, that being orange and blue. And then you can kind of see how they kind of both started at that 0, 0 position, and then they were kind of able to kind of hit all of the goals that they wanted to, and denoted by those green target points here. And you really see kind of the use case of cuOpt kind of running and being able to make sure it's finding these optimized paths here. So this is another quick example that you can run, and you can see it's what we have on the output in our documentation as well. And then finally, I think this one is really cool. This is us actually playing with our Isaac Sim UI, and we're actually going to be loading a warehouse scene here. So kind of, again, not saving the scene, going back to my cuOpt window, and then loading up the transport demo, and then again going to have to be putting in my credentials here. Copy, paste. I'm gonna test this. And so loading this simple warehouse environment, it's gonna take a second. And then, so very cool. We see this warehouse inside of Sim from the outside, but if you go, if you go Shift S, okay. Just kind of, you see it's a simple warehouse that you can zoom in and zoom out of. I'll be going over the code for this example in a second. I just kind of wanted to run through all the previous examples, and then this one kind of just really shows and kind of connects all of those pieces together. So let's load our waypoint graph here. So let me just kind of like move this onto this side actually. Okay, let me close this and this. So as you can see, again, this is a little bit more of an intricate waypoint graph that we have here with possibly multiple stops, multiple locations, and you can really see the use case really if you're trying to send a couple of vehicles running around in your warehouse, what is the most optimized kind of way for them to navigate through this without in the most optimized manner. So great. So we've loaded our warehouse. We've loaded our graphs here. Now let's load in our orders, again, denoted by those green dots. And then finally, let's load in our vehicles. In this case, we have 2 vehicles loaded, and and let's kind of, if we want to, so let me just kind of also follow the documentation here. So again, what we've done, we've loaded kind of our scene, set up the credentials, and then we've kind of done the orders that appear in green and the vehicles that are starting at 0, 0. And so another really cool thing is that you can create these semantic zones. So these semantic zones can be areas that you do not want the, like, let's say vehicle to, that's kind of like you want an area for it to avoid. So let's try actually generating that. this has been working in and out for me. So we'll try to see if I can get it to work or not. I'm trying to see where it loaded, but I don't think it did. Regardless, that's I can try looking into the code, but I think that that's a really cool kind of just option that you have, so that cuOpt kind of recognizes that this might not be an edge between these two nodes. Let me kind of reroute and optimize another path planning kind of thing for this. So let's kind of generate. Let's update and solve. Sorry about that. Just kind of want to give you guys a visual kind of view as to what you're seeing here, and so. It's a really great way to kind of visualize everything that you see going on. Again, the two vehicles are being denoted by these orange and blue kind of like routes here. And so yeah, this is like a really cool example that you can go through, and you can really see how it's applied in real world scenarios and use cases. Again, the output here that you'll see the solution cost for that, and then also the vehicle that the route that each vehicle takes. So yeah, I think that that's a pretty cool example, but let's dive deeper into kind of the code here and see how all of this was able to happen. So this is the code. By the way, just a quick highlight. Each example that I went through kind of has this icon here on the top right of this like independent window, and so this will open up my VS Code. So if you're interested in kind of like looking in through the code for all of these other examples that we have, more than welcome to. This will also kind of like open up the folder to kind of just like just in particular, for example, for this transport demo, but everything is accessible, so you can go back and kind of look throughout the code and see how you can implement this for your own use case. Let me make this code a little bit bigger for those to see, because I realize it's kind of small here. But sorry, don't mean to cause blinding here, yeah, just I know I didn't go through all the code, but again, it is all available for you if you were interested. So I'm just kind of going over through the overall kind of setup here. So we have this class that we've called this kind of like microservice extension, and then you're kind of like importing where, for our cuOpt sake, if it's a microservice or if it's a managed service, you're kind of going through all of the assets that you want to kind of load in. If it's like for example, warehouses, vehicles, etc. Then these are a couple of other kind of functions that we have in order for us to make sure that we're getting all the information from the UI to either load these waypoint graphs, these warehouses, etc. So kind of just going a little through here. So yeah, this kind of work either if it's a managed service, going through here if it's a microservice, and then the real kind of code for this use case and where we see cuOpt really in action is if you scroll all the way to the bottom and in this kind of function here with running cuOpt, we have kind of solver time limits, the pre-processed data that we're getting from our waypoint models and the objects and the vehicles that we kind of initialized up in the beginning, and then kind of going through kind of the data, but then right here is kind of where we're actually, we're setting up what the server from whatever URL we're using, again, managed or microservice or managed service, and then kind of like making sure that we get the routes from the environment data that we were able to set up here. And so, and then the cuOpt solution is returned as our routes, and then we get our response, and then you kind of visualize those routes here, and then you set the the final output that we would get here from the route that the vehicle, for example, took is denoted here. So that's kind of a basic rundown as through how the behind the scenes as to for this demo in particular. But yeah, we kind of ran through all of the examples available in our official Isaac Sim documentation. And yeah, Edmar.
That's amazing. Well, listen, that was mind-blowing. You are a natural at this. So I'm so glad that we got your monitor situation fixed. I think that was so helpful to everybody.
Yes.
So thank you for that. It reminds me very much of Ashley, your Learn With Me series. I love it.
Yeah, are we saying that Edith needs to take those over? Is that what you're proposing right now?
Oh, okay. I love that. This was really helpful, and I'm so glad I got this to work. And happy to answer any questions or any.
Okay, cool. Yeah, I think we started a few actually. So
Awesome.
we've got one from George here on LinkedIn. Let me put it on the screen.
Mm-hmm.
Can the nodes and edges be created from the script editor with a spreadsheet for the location information? That's number one.
Mm-hmm.
I want to take this one.
I can take it. So for cuOpt to be running these graphs automatically, it needs to be in a certain format, and that's what the create network does. It creates a network in a certain format that cuOpt understands. That being said, if you go through the code, it's pretty simple to map your spreadsheet to what cuOpt can ingest.
Amazing. Okay, cool. That's good. Here's coming from YouTube, Mr. or Miss Robot 4RL. If I run through Jetson, can I run cuOpt offline using local GPU solver from Jetson?
So
There's
I think
also like a, yeah, sorry, Ashika. There's just a continuation to the question as well, which says, or set cuOpt on workstation offline and then publish path to each robots.
Thank you.
Yeah, so the way cuOpt works right now is two different ways. One is the managed service, what Edith just demonstrated, and the other way would be running cuOpt on a remote machine which has a GPU, and it would have an API which you can connect, endpoint which you can connect to via an IPN port. So if you have a GPU remote machine, you can run cuOpt there, and Isaac Sim can just send your data to that solver and get back the routes and locally reroute the AMRs.
Mm-hmm. Yeah, and so this is just also just to add on to that. If you're kind of like interested, we do have support for like CUDA 13 as well and CUDA 12. So whatever kind of your workstation is kind of running on, we do have support for that. So I also kind of tried the microservice on the background too. So yeah.
And I would add that whoever has a Jetson already, the exact example that Edith showed right now with the Isaac Sim documentation, you can't run that on the Jetson because the Jetson isn't meant to run simulation. So the same example, maybe not, that you'd have to run on a separate workstation with a GPU. But then when it comes to just like publishing or communicating the route, I think maybe that could be done through ROS or like some faster real-time protocol like that.
All right, great. And you know, I love these next two comments because they're coming from a fantastic developer I just met the other day in New York City from Electron Robotics. We'll show his page off in a second. But he has two comments here. One, he just shared a second ago. This is great. With OmniCore's APIs being deprecated, which is on the script, or is that because you're using Sim 4.5 and have the cuOpt APIs already been migrated to latest Isaac Sim 5?
Right. So I am running this example on 4.5. Ishika, I know you tried writing. You ran this on 5.1.
I did.
Okay. Great. All right, that's good to know. And the question that, or a little earlier, I'm going to time travel a bit. Once a scene is generated with nodes and edges and saved as a USD, can I run cuOpt directly through the core Python APIs, or is it only accessible via the Isaac Sim GUI?
No, you can definitely run it via the Python APIs. That's not something we have showed in the examples because it's generally more user-friendly to do it from the GUI, but we can run it directly through the APIs. And that would be much faster.
Okay, that's great. Well, that's good to know. And okay, I think we're caught up with a lot of the questions. And I do see a video here. Bertrand, is this something you wanted me to share? I forget who wanted to play the video. Was this Ashika? Was it you?
It's Ashika. Yes.
Oh, sorry. Okay, so you want to put that on screen?
Yes.
Okay, here we go. Let me see.
Okay.
All right, you have full control now. I'm hands off.
Yeah, I'll just go through this quickly. So thanks, Edith, for walking us through the documentation and the tutorials. That was very in-depth. So I just want to share a quick video here showcasing the design aspect of warehouses of a digital twin factory. So that's just another aspect where cuOpt can increase the efficiency of the warehouse production line. So obviously, Isaac Sim helps you create this digital twin of your warehouse to simulate the entire production line end to end. And where what you want to be doing next is to enhance the routing and the design of the factory so as to minimize your time and cost efficiency right from the assembly to the delivery of the end product. And that's where cuOpt can help. So basically, imagine this is a factory, right? Created using Isaac Sim. And this is at a very small scale where all the robots or the AMRs are stationed at certain locations, and the assembly machines and the storage units are also placed at certain locations. And this is your initial design of the factory, and you are just trying to traverse the routes through the entire assembly sequence. The sequence may be like there are some machines that do certain assembly aspects, and then the robots pick them up and deliver it to certain destinations. So you already have your pre-planned routes and the design of the factory ready. That would, on the higher level, in this particular factory, would look something like this. So as you can see here, the way the factory was initially designed is having all your AMRs and bots stationed at the far left, and probably all your storage units and particular machines stored at the back of the factory. And this is a very initial factory design of yours. What cuOpt can help here is it can help you figure out if a new factory design or multiple factory designs are feasible, and if that reduces your cost of planning or production and increases the throughput of the factory. So for example, and this is a very simple example, but this is just showcasing what cuOpt can do on a larger scale. So suppose you want to see what if you move all the robots that are on the far left to a more centralized location, and maybe redesign where your machines lie and where your storage units lie. So let me just forward it to that part. Yeah, right now with the initial design, this is what the route would look like. Every bot is starting from the far left, and they are reaching the destination, which is shown by the red and the green routes, right? So you can already tell this probably might not be the most optimal route for the factory. So what you can do next is redesign your factory and try to see if that helps. So for example, you move all your bots which are to the far left to a more centralized location, and maybe change the locations of certain machines. So something like this. You can use cuOpt immediately to resimulate your whole path, and it would look something like this, right? So this immediately tells you that this is a much better optimal route, and this design is better than the previous one. But in a more large scale setting and in a more larger factory, I think cuOpt would be a beneficial tool. cuOpt and Isaac Sim can be a beneficial tool in simulating all these hypothetical scenarios and deciding whether redesigning the factory is actually something that you would want to be doing or not, and how much more efficient can your factory get using these redesigning strategies. And even apart from that, I think what cuOpt can help is, in a large factory, there are a lot of unprecedented events. For example, some product spills on the aisle, or an aisle is closed off for maintenance issues. So cuOpt in those scenarios can, in a fraction of seconds, give you an equally optimal route, keeping into consideration that there are some complications in certain aisles which are inaccessible. So even that can help in reducing all the delays in a production factory, and that can save you, in terms of cost, it can save you billions if the factory is on a very large scale and is very high in demand. So yeah, and I think Edith and Burchin have already gone through how you could access cuOpt online and all the documentation to get started. And I would be very excited if folks here can try it out and let us know how it goes for them.
Yeah, I think it would be great. On the Discord server, we have a channel called Show Your Projects. If people do start working with it, we'd love to see some of your work. And maybe it's something we could highlight in a blog or future live stream. So absolutely, don't be shy about doing your work in the silo. Feel free to share it if you're allowed to share it. I think, Ashley, you wanted to clarify something that was mentioned earlier, right?
Yeah, I just want to make sure that everyone is like 100% aware that we are here to accelerate developer platforms, accelerate developer ecosystems. And so I congregated everyone here together so that we can highlight all these great open source libraries that NVIDIA technologies enable, from cuOpt to CUDA, IsaacSim being a platform to have your robotic simulations. And when I caught that Omniverse core APIs were being deprecated, I wanted to just make sure that everyone is aware, if you're using Omniverse core capabilities like OpenUSD, RTX, our AI infrastructure, all of that is still available. It's not going anywhere. And at SIGGRAPH, we announced that we're just going to be making it easier than ever to incorporate Omniverse into your own applications in the same way that we do for CUDA and cuOpt. So those are on their way. Some are available now, like the 3D Gaussian spotting. We'll post a link to the press release where you can get more information on that. But just in case anyone else saw that and was like, wait, what are you talking about? Where all of this is to help you do all of what you want to do just easier and with less friction.
I'm so glad you called that out. I did post that link in the chat on both LinkedIn and YouTube, so it's there for everybody to check it out. That's an announcement from SIGGRAPH timeframe. We have a couple of good questions here. I think that have been starred. Let me see. Let's take this one from LinkedIn. The intro warehouse transport demo allows creating semantic zones to assign a high travel cost. Does the cuOpt service also support dynamic updates to the waypoint graph's edge weights, for example, from real-time perception of obstacles or congestion during the optimization run, or only before the solve request? Who wants to take that one?
I can take it. I'm not sure I understand the question entirely, but
take a stab, and then they can clarify in LinkedIn if they want.
Okay, yeah. So what's happening in the last tutorial, I think that's what you're referring to here.
So, yeah.
So it does update the edge weights in real time, but that information is sent to cuOpt only while rerouting. So cuOpt is not aware of the change in the edge weights, but IsaacSim environment is aware of the change in the edge weights, if that makes sense.
Okay, cool. Thank you for that. And if you want to clarify, viewer, feel free to do that. We have another comment here coming from YouTube. This is also a few minutes ago. Can this node network be made from an occupancy map automatically?
Yes, it can. And I think internally we do have some workflows that do that. It didn't serve us the best to showcase it because the demo, that's not what we needed in the demo. But yes, it can be done with an occupancy map.
Okay, that's fantastic. Okay, great. I think, let me see. Sorry, or anyone, do you see any other questions from the live chat you think is important we take now? I've also posted the link in the chat a little earlier about pointing people to our Discord thread we have on this live stream. So feel free to follow up with any questions or comments in that thread that I posted earlier. You have to be a member of our Discord server, but that's just a click. And I did get a question here I can take really quickly, asking about if this replay will be available. the replay is not only is it available, it was available 1 minute once we started. So you can go to YouTube. The same link will work right away. So you can right now you can go back in time and watch a couple minutes ago if you want to see that great video from Ashika, or you want to see the demo. But that link is permanent, so it'll always be there for you. So I highly encourage just go to our YouTube channel for NVIDIA Omniverse and go to live, and you'll see all that stuff. Look at this. We got a question from Cape Town. Okay, hi guys from Cape Town, South Africa. Well, who wants to read this? Who highlighted this? Ashley, was this you?
I did. I highlighted that.
You can read it. You can read it.
Not a question, but it was just nice to see. It says got into the developer program today, and it's awesome to see how active the community is with calls like this. This is great. This is why we do these.
Yeah, thank you so much for watching. And I did, I was at GTC with some of you a few weeks ago, as well as this developer meetup in New York City a couple of days ago. And I hear constantly from developers from all different size companies, from solos to small teams to startups to enterprise companies, how helpful they find engaging with developers like you all here. So thank you so much. I have to give a big thank you to Bertrand. He had to go to a meeting, so that's why he couldn't say goodbye, but he said goodbye in the background, so I'm saying goodbye for him. So thank you, Bertrand, for presenting. That was really fantastic. Okay, so I always like to do this late. I think it's super helpful. We're going to go around, and I want you to kind of let the viewers know what you think the one main takeaway from you think that they should be taking away from this live stream. Hopefully they watch the whole thing. There are many takeaways, but what's the one thing that you want them to walk away with this? We will start with Asari, because I feel like she's ready.
Yes, one main takeaway. Watch the recording if you didn't get to watch the whole thing. And the Isaac Sim tutorial is out there. I know a lot of you have Isaac Sim installed because we have recurring, people come on the office hours. So just try it out today, honestly. It shouldn't even take that long. Just try it out in Isaac Sim. Tell us how you feel.
That's a great takeaway. Ashika, you're next.
Yeah, I think that's what I think it's pretty accessible and it's open source. So please try it out and give us feedback, because we also want to improve at the same time and make it much more easier for you guys. That's
great. So where do you suggest feedback come? Do you feel it goes, should it go on the official forums? Should it go on Discord server or GitHub? Where are you guys checking feedback the most?
Specifically for cuOpt, we do prefer GitHub because we are constantly keeping track of it.
Okay,
but
cool.
For Isaac Sim and cuOpt, I'm not sure. Yeah, maybe the forum would be the ideal.
All right, cool. That's great. Okay, Edith, you are up after that amazing demonstration. What do you think the main takeaway is?
Yeah, I mean, hands-on. I think get your hands dirty, try it out, and then, give us feedback, because at the end of the day, we are always thinking about you guys as the end users, and we want to make sure that this process is as easy and simple for you guys to really implement in your use cases. So yeah, just try it out.
That's great. And thank you so much for working through those technical issues before. It was well worth it. Ash, what do you think?
Join the community. All of this is because the community is so active. The office hours have been developed because the community is so active. Our community live streams that we host on Wednesdays, the Learn With Me's that I've done in the past that might come back in the future, like all of that is because the community is so great. So Discord, forums, hanging out with us on LinkedIn, being a part of our YouTube channel, all of this is because you guys are there.
Look at this. I did not make this up. This is coming in as you were talking from Hillary. Yes, I recently joined the NVIDIA Inception program, and I'm blown away by the developer community and all the great resources from NVIDIA. Thanks all. Well, thanks to you. You're the reason why we're here and why we are so excited about sharing this stuff, because you're the ones that make the magic from the technology that we work on our side, and it would be nothing without you. So thank you so much. And I would say for anyone who's watching this and you're in a startup, Hillary just referenced Inception. That is NVIDIA's starter program. I cannot say enough good things about Inception. It's a great place if you want to get introductions to VCs, funding for cloud credits, and there are no strings attached. So just do a search for NVIDIA Inception and you'll find out all the great benefits. I have a video maybe I'll play after I let our lovely guests go, even more of an overview of Inception. All right, so I am going to let everybody go. This has been fantastic. I'm going to go over some news now for everyone who's watching. Don't hang up yet. There's some news announcements coming and some blog posts, but I do want to let my colleagues here get back to their meetings and their and their workday. So thank you so much, Asari, Ashika, Edith, and Ash. Very compelling live stream, very informative, and I think that this is going to be a great resource for people for a long time to come. So thank you for putting this together for us.
Yes, thank you all for joining. See you next time.
Thank you.
Bye. Thank you, guys.
Bye.
Hi, thank you.
Okay, there we go. And you get to see my head just for 1 second here while I change the screen to we have a presentation here for our new slides, which has been prepared by Samantha Young. So thank you for that, Samantha. The other thing while I'm bringing this up, I want to acknowledge some great support preparing this live stream, not only from Ashley, but other people on the team. Amelia is not here with us today, so we wish her well. She's a little sick, a little under the weather. She's fine. She's fine. I'm chatting with her, but she need to take a little break. So we wish her a speedy recovery, but she's always helpful for producing all these live streams in the background, even if she's not here rarely on a live moment. She did a lot of work for this beforehand. All right, so I just mentioned NVIDIA GTC DC. You know, there's never a GTC that's too far away. The next one's coming up in San Jose in March. I'll be there. I hope you guys come. The one we just wrapped up happened in Washington, D.C. First time branded as a GTC conference. We've been there before for AI conferences, but this is now officially a GTC conference. It was amazing. It was absolutely fantastic. I met so many great developers, so many amazing sessions. It was just, we had a great time. So our content from there is now available. So you can grab these on-demand sessions. You can use your phone to snap that QR code. I highly encourage people to check out the sessions. This session on the screen actually was fantastic. That might have been my favorite one, actually, of all of them, panel led by Rev. So I highly encourage that. You'll see all those sessions by flashing that QR code. And then we've also recently launched open models and data to accelerate AI innovation across language, biology, and robotics. So please check out that code for more information on that work. I'll leave it on the screen for just another second. Again, if you miss this QR codes, this is available on YouTube, so you can go ahead and watch it anytime and go slower. Physical AI demos from GTC are also now available. The team have worked really hard to get all this content up as quickly as possible. In some cases, less than 48 hours, but I think most everything was available within 3 days, which is great. Normally you have to wait a week or more for if you're not at the conference. But there are all the demos available for developers out there. This is a great story. NVIDIA and U.S. manufacturing robotic leaders drive America's reindustrialization of physical AI. Obviously, everyone here watching is very familiar with physical AI and working on it yourself. So I would check out this story on the work there with other companies and NVIDIA. NVIDIA, as noted earlier, we are contributing a lot to open frameworks. This one will cover all the next-gen stuff for robotics development. So check that out. It's something that we're super excited about. Jensen himself talks about how pleased he is to see so many things go open source and available to everybody. And one of our main missions is making things as accessible as possible. And the results there are already showing themselves to be amazing. We're seeing so many projects from different size companies, so many different ideas that just would not have happened otherwise. So kudos to everyone out there leveraging all this great content. Isaac Lab 2.3 now generally available in open source, OmniPhysX. Check it out. I think Asawi just mentioned that a little while ago in this live stream. There's a QR code. We have a lot of great resources. Like we mentioned the forums already, we mentioned the Discord. On the Discord server, there's also an Isaac Sim and Isaac Lab study group that meets every week. And it's super lively, great bunch of developers of all areas and from different parts of the world. So I would check that out. That's on our Discord server every Wednesday at 12:30 p.m. Pacific. It's a live event, so they just meet up in a room. It's on our ad event calendar. I posted that in the chat earlier. But you can go any Wednesday that's happening. If you're watching this live, it's starting in about 10 minutes or so. Otherwise, Wednesday at 12:30 Pacific. Usually led by Omniverse Ambassador Scott Dempsey, Moramar Bay, otherwise known as Lychee AI, and several others in the community are really, Papa Chuck is there, community champion. It's a great time. So if you want to learn a little bit of Isaac Sim and Isaac Lab in a very casual environment, go to that study group. I can't recommend it enough. Not only we meet great people, but you learn a lot of great stuff. Startups and ISV save 20% off Jets and Thor. This is a great, I didn't even know about this slide. Wow, cool, that's awesome. So use that code. Look at that crazy QR code. That means that there's savings in there. That's what all those dots mean. 20% off, so leverage that. Well, I'm gonna keep this on for another second or so. Justin Thor is obviously super exciting. And we're so happy to see people leverage that. We saw a couple questions on that earlier in the chat. So take full advantage of that nice coupon. NVIDIA Isaac Root and the robot. How awesome is that? There's a QR code to find out more about leveraging Groot, which we've covered many times on this live stream. I hope that this is something that everyone can take advantage of. R2D2, perception guided task and motion planning for long horizon manipulation. R2D2 also something which has been celebrated a lot, including at GTC. Use that QR code to find out more there. And let me see. Here are our evergreen links to some great resources. I mentioned Add Event Calendar. That's what's that. That's the QR code under events there. That tells you all about our upcoming live streams, our study groups, our office hours, and other major events like keynotes. We put them on that Add Event Calendar, which makes it easy to add your own calendar with just one click. You can subscribe to the whole calendar or just pick the event you want to make sure you don't miss. Our support forums, which I mentioned earlier, that's where Isaac Sim support is handled officially, and other tech. The difference there, I think we mentioned cuOpt and also Isaac Lab is handled on GitHub, but most other things are handled on the forum. So that's the link for there. Our Discord server, which I wouldn't really lean on for official support, although it does happen there on a more inconsistent basis, I will say, because the developers on our team are focused on the forums. But we do have people like Richard Yartlett and others who are super helpful on the Discord server answering questions. Just make sure you put them in the right channel. But that QR code will give you access to our Discord server, which of course is free. And if you need any help using Discord, you've never used it before, feel free to reach out to me. I'm happy to give you a walkthrough. You can always contact me on LinkedIn by going to edmar.net and just send me a note. Ambassador page, actually, we should change that label. That's our community page. Our ambassadors are on there, which I love, and we just announced several new ambassadors. I mentioned this last week about who we brought in, so I'm not going to go through each of them. But if you want to look at all of our ambassadors, including the new ones, go to the community page. They're listed there, along with every other resource, including our Add Event Calendar. All that stuff is there. So community resources, we talked a little bit about earlier about how helpful community resources are. That's the link that'll bring you right there. I'm going to stop sharing the screen. I know I just returned from New York City. I just wanted to say, just for a quick minute, I want to give a shout out to the developers out there I met with. It was relatively a last minute kind of thing to meet with some robotics companies. And I have to tell you, it was amazing. And the reason why I'm bringing it up to everybody here is that I would like you to let us know where you would like to see a meetup in your area. I was shocked by the response I got when I posted on LinkedIn to some people in the New York City area that are leveraging Omniverse and Isaac Sim and other things for robotics, if they would be interested in a meetup on a Saturday in New York City. I got such a great response. We had a great meeting, and what you're seeing on the screen now is result. Big thanks to Jessica G from our team, who may know, who works with some of our amazing influencers in the world that are talking about our tech stack. So she helped a lot with this event, and as well as giving a nice intro to the New York City NVIDIA office. So this is a group that we met with, and it was hosted by one of the developers I was watching today's live stream, Naranjan from Electron Robotics, that was at their office. What a great, look at it, great people there. It was just a lot of fun. Again, I wanted, as Sherelle Liu was there, many people recognize her from the community. And it made me realize that I think we need to do more to go attend certain cities and kickstart some of these meetups. The thing I heard pretty consistently from the attendees that were there, and the ones that couldn't make it, I met with on Monday separately while I was in New York City, that they would love to engage with more developers in the area, leveraging Omniverse, and have these in-person meetups, and potentially we could help with speakers, and which we would be happy to help do anytime we can, whether someone lives there locally that could speak, or we can bring someone in virtually, or it's someone like me who can help and connect some of the dots for you. But big thank you to Electron Robotics. Here's their webpage. I would check them out, doing some really cool stuff. Look at that, pick and place. They were actually, look at that, they're working with sausages. We did talk about that in that meeting. They are a really interesting, fast-moving team. I would say that this is a great company to watch out for. So they're leveraging Isaac Sim and soon to be Isaac Lab. So big thank you to them for hosting our meetup there. if you are interested in doing a meetup in your area, I would say please let me know if it's something that you would like our support with it, and I'm happy to try to help. Just send me a note and say, hey, I'd like to get a meetup going. I'm thinking about doing North Carolina next, and the Triangle Hub. So if you're watching, you're from that area, let me know. And this is our Ed event page. So we posted this a little earlier. From this page, you can see about all our upcoming events, our live streams, and here's a great live stream that's happening next week on the 19th, Safety in the Loop, Develop Safer Robots with NVIDIA Halos Outside in Perception. We've been talking a lot in the planning stages for this today, actually. This is going to be a great one. All of our stuff is on here, and including the Isaac Sim and Isaac Lab study group I mentioned a few minutes ago. That's happening in just a couple minutes if you're watching live. We also have another study group that is spawned from Michael Wagner, Omniverse ambassador. That's happening for German speakers, but I think they're actually considering making it for English speakers because they got such a high demand for it. And that happens on Friday mornings on Eastern time, and later in the day, obviously, if you're in Europe. But anyway, leverage this calendar. We are happy to help with anything that we can support you with. So let us know if there's something that we're not doing. Thank you so much again for the guests. Thank you so much for all the great comments, questions we got throughout the live stream. Really enjoyed this hour with you and bringing out some new people here to chat with you. I look forward to next week's, but in the meantime, I will see you on Discord and on the forums or on LinkedIn. If you want to find out more about some of the companies that are doing really cool stuff, I would say follow NVIDIA Omniverse page, follow NVIDIA Robotics page on LinkedIn. You're welcome to follow my page. I try to repost and share everything I can find that's I think will be worthwhile to others. And word on the street is that the Revel team is putting together another hackathon. That is super exciting. Everyone remembers we covered their last hackathon on the live stream. And this one looks to be a significantly bump up in many ways. I don't want to give away any secrets because they're going to announce it very shortly. But I would say it's going to be very exciting. Okay, thank you, everybody.